And now it's time to move into our last speaker for today, which is going to be our long talk from Ben Weinstein. And he's going to be sharing more about Deepforest, which is a Python package for airborne object detection focused on biodiversity monitoring. So Ben, whenever you're ready, share your screen and take it away.
So good morning, everyone. Thanks for having me. I want to take a little bit of time to talk about Deepforest, which is a Python package that we've been building for a number of years now on covering airborne object detection, mostly from unmanned aerial vehicles, but as well as manned aircraft, and less so satellite. And one of the things that Deepforest grew out of was a project with the National Ecological Observatory Network, NEON, to build a model for tree detection in 10 centimeter imagery for the NEON sites in the United States. It's a very large group of about 45 sites with simultaneous data collection for biodiversity as well as airborne data collection. And so we made that tree model available a number of years ago. I won't go into the technical details of it, but it's a semi-supervised deep learning model utilizing LiDAR pre-training and then RGB hand annotations. Um, and Deep Forest is this funny thing because when we first made it, we didn't really realize what we were doing in the sense that it was never our intent to build a tree detection model for being applied to everywhere on Earth. It was really meant specifically for neon sites. But what happened was that within just a few weeks, we were getting dozens and then hundreds and then just again and again over month periods downloads, trying to apply it to all sorts of forests, all sorts of tree types, all sorts of different things. And so it became really clear to us that the community needed something that, in fact, we had not really trained for. And so Deep Forest itself grew out of this need that the community drove us towards a tree detection model at a global scale across resolutions. But the truth is we were still working on Neon. And so we kind of kept working on Neon sites. So we have a visualization server up that's worth looking at if you want to look at 100 million tree crown predictions. We worked on tree species classification for 80 species in the Neon sites. And we had this tree detection algorithm, but there was this funny mismatch between sort of what we were working on and then what the community kept sort of adopting it for. And so we started to really try to build Deep Forest as a Python package where you could fine tune a tree detection algorithm to your local sites. We never think of the tree detection algorithm in Deep Forest as a zero shot tool for anywhere on Earth. I'll talk about that a little bit at the end. But it was this fun dichotomy between our sort of normal day-to-day research and then this open source tool becoming ever more used. We were developing these broad scale predictions of tree species in different sites in the United States. And I think these pictures are super beautiful and really interesting from a macroecology perspective about looking at tree species distributions at these broad scales. You see things that are genuinely Poisson random distributions and then these highly patterned environmental structures, things like water. These are like water channels, for example, with these different species or elevation gradients. You're looking at a ridge versus things that are nearly random distributions in the landscape. And so we were interested in studying these different tree species patterns and tree species maps within the broad landscape. But deep forest kept kind of coming up as a thing that needed to be worked on. And so we developed some expertise in computer vision for airborne object detection. And we kept looking around for what are the other pieces that people need. And so I think in 2022, we spent some time building a bird detection model. So this was for airborne object detection of just a single class bird. And we developed, I think it was 13 or 14 different projects that we went around looking for open data for tree detection was a starting point, and then we built from that tree detection model a bird detector. And so it really was a nice lesson on how fine-tuning from one environmental algorithm can be used for another algorithm. And so starting from tree detection, we built a bird detecting algorithm. And this thing has been used again, hundreds of times now in a place that we just weren't really expecting. And so we're continuing to sort of build our own research program, but at the same time, using Deep Forest as an open source tool. In our own work, we're working on restoration and monitoring in the Everglades. We're part of this very long-term project started by Peter Frederick in the 1970s, where they were surveying 6 species of conservation concern. These are large egrets and ibises in the Everglades. And the task was to count all these birds in the colonies and try to get an understanding of nest detection and nest success. And so we've been flying drones through our field teams. A great credit goes to Lindsay Garner and the field team's work. It's incredible to watch someone land a drone on an airboat next to you. It's quite something to see. Um, and so we have 1 centimeter imagery for a lot of bird colonies, and we were developing tools to count birds as well as try to estimate nests. And so I wanted to share this briefly because I think it might be a tool that others could use. Imagine that you have a set of orthomosaics and you go back to the same site every week or every month, for example, depending on your nest frequency. If you look and you have them georeferenced, you could overlay them and use the detections from our bird detection algorithm to look at how often birds are found in the same place. So if you imagine you have 8 orthomosaics, each taken in a different week, and you overlay all of them, you might imagine that if a bird's in the exact same location or within a couple meters in, say, 6 of the 8 weeks, that might be good evidence that there's a nest there. Why would there be a bird in the exact same location over time? And so when we have these georeferenced objects, we can start to estimate nest frequency and nest success. And so we've gone and validated this using field surveys, and we're more than 75% accurate in detecting nest locations. And from that, we can get time series of nest success. And you can imagine that we're now monitoring, 5,000, 10,000 nests at once, about which ones fail, which ones start, all these different environmental features that are associated with them. So I thought this was a nice example of how computer vision algorithms can be combined with sort of traditional ecological tools. And I'm happy to share, and we're always interested in collaborators here if you're interested in the ecology here. I think there's a lot of statistical work to be done in the hierarchical Bayesian world about these kinds of developmental models in collaboration with airborne computer vision. So just moving briefly through other pieces of deep forest, because we just start with trees and we're with birds. We have a livestock model, which is relatively under-tested for things like cattle and other pieces. And what I would really love from the community is if you could go to Deep Forest and the GitHub repo and just start listing what are the kinds of data sets we need, what are the kinds of models we need. We're interested in these broad scale detector models, not necessarily individual species classification, because there's 10,000 species on Earth that we might make a detector for. So we're interested in these broad scale models and how we best serve the community. And so we would love to hear from everyone about how to build airborne models that best suit people's needs. We annotate data, and I was sort of saying before that we never think of these models as zero-shot tools. So there are fine-tuning tools within Deep Forest, very simple, 8 to 10 lines of code where you can open a Deep Forest model and then annotate your own data and then fine-tune for your specific ecotype. And that vastly improves the model performance. We're not really at a place for zero-shot generalization at the global scale yet. Deep Forest is this funny thing, and anyone who knows me knows that I have like endless sort of concerns about it, which is that sometimes it feels like a very simple thing that it is not worth a ton of our time. And then it consistently has this uptake that we don't always know how to well to explain. So we're at 5,000 downloads a month, nearly over 200,000 downloads now. And we try our best to understand which are bots and which are real people. But it seems to have consistent usage for both the tree and bird and livestock models. And so if there are Deep Forest users in the room here, and I recognize a couple people, please let us know, how we can make it better. Deep Forest 2.0 will be coming out soon with a vastly improved tree model in collaboration with the World Resources Institute, and Global Forest Watch was mentioned earlier. We work very closely with WRI, and it's this interesting piece about how we build community around simple tools and thinking about what Deep Forest needs to be to make it available to a large audience. Because I think what is really important here and for this conversation is how we talk about sort of building community. I'm working on a number of benchmarks, and I'll talk about Million Trees in a second, but I'm working on similar things with wildlife as well. And trying to understand the data sharing process and what expectations users have for attribution and data storage and data sharing, especially in the airborne object detection community, is still really difficult and involves a lot of personal relationships. And so I spent a lot of time emailing hundreds of authors. Hey, can you make your data available? Can you make your data available? What would it take to make your data available? if we destroy the geospatial location so that no one could tell where it's from, so that the annotations are only referenced to the upper left corner, how do we think about reducing duplication? There are a number of packages out there and how we create interoperability. So I'm in conversation with the Torch Geo community, for example, on occasion, trying to think about what that would take. PyTorch Wildlife is working in some similar areas as well. And so trying to build that sense that we are in this together is a very important and I think underrated part of this. And so I'll talk a little bit about Million Trees that'll kind of emphasize this. So I'm currently working on the Million Trees benchmark. It is a very large effort funded by the World Resources Institute to try to come up with more than 1 million, we're already at 1 million, views of trees from annotated airborne data. So that's polygons, points from drones, from manned aircraft, a little bit from satellite, although individual trees from satellite continues to be a bit of an open question about what's worth doing there. And so we're looking for field verified data. So if anyone here has geospatial data of tree locations and corresponding airborne imagery, we would love to include you. Everyone is welcome to be an author on the first submission. As I said, we destroy the geospatial location for the data so that no one can use your data in any other capacity. We don't take any species data or DBH data. We're just looking at tree location right now. And the goal is to try to release a large benchmark that measures performance in, as deep forest users have been doing, on zero-shot global airborne tree detection. And so if you train a model in Malawi, how does it generalize to Mozambique? If you train a model in England, how does it generalize to Australia? These are the kinds of questions that we don't really know as a community right now, and how the best way to adapt these pieces. So we're at, I think, 1.2 million tree views. It's not exactly 1.2 million trees because sometimes we have multiple airborne slices of the same tree. So those are different views, but they are the same tree. So it's a little bit hard to know exactly how to count the numbers, but it's a lot. But the truth is, and I was talking about community building, I think it's only a 20th of what's out there. If I had to guess, and knowing all the people and knowing the conversations. So if anyone here works with Forest Geo, we haven't had a lot of inroads there and necessarily GeoTrees as well. And so there are large efforts that exist, but we haven't been able to create the kind of collaboration that we're looking for to kind of build a community around these kind of ideas. And so I think that there's probably 25 million views out there that have already been annotated, and we have about 1 million of them. So that's good, but I would say not great. And so thinking about how to move forward and create collaboration and the right kind of attribution, because the view of the benchmark is to try to create a kind of broader understanding of what it would take to build models that generalize across space. Right now in machine learning, for example, if you take an off-the-shelf machine learning algorithm, you might have a point model or a polygon model or a box model, right? So you have a neural network which incorporates information about a specific geometry type. But if we step back, that's kind of absurd. If a model knows something about tree boxes, it also knows something about tree polygons. It also knows something about tree centers. And so we want to design a benchmark that transcends this annotation geometry and allows us to capture data from a broad array of tools. And so instead of designing a benchmark for what existing algorithms look like, MaskRCNN takes in polygons and RetinaNets takes in boxes, we want to promote this idea that we need algorithms that are annotation agnostic or annotation geometry agnostic and incorporate lots of different types of information. And so some of these token-based models that have been promoted in the remote sensing imagery community are really interesting for that reason, and trying to encode information from multiple geometry types, because that's the only way we're going to get a truly global model is to incorporate information from all these different pieces. And so that's the sort of one way we're building community. I want to also promote that we are thinking about a similar, I'm going to call it like million animals benchmark, where we're looking for airborne object detection for wildlife at a global scale. And so trying to rally the community around the same idea. This would be a Python package. You would pip install Million Trees and you get the data and you load it automatically. And so you just say, hey, I want the data for this country, and you're going to get it loaded there. And so we're thinking about the same thing for wildlife. We've identified 276 different teams with wildlife data from airborne perspectives. And we haven't contacted that many yet just because we're thinking about building this into our next grant cycle. But if you're interested in building an airborne object detection model for global wildlife detection, a little bit the way Mega Detector works on camera traps, where it's sort of organism agnostic, that's something that we're interested in as well, and creating community around this. And the last way we're creating community is credit to Wild Labs. The Wild Labs Boring Fund 2025 funded an AI development workshop in Latin America that we just finished in April. That went really well. And I want to stress to everyone here, I think one of the takeaways is that this stuff is possible in a diverse set of different countries. And I think we've really proven that you can find 25 to 30 people in almost any major city in the world at this point who are interested in AI development for biodiversity. And so we were really surprised about the quality of the students, the commitment of the students. We did 4 days, one on camera traps, one on airborne data, one on bioacoustics, and we showed how to build models, how to share data, how to build general reproducible knowledge using GitHub. And so it was a really successful effort that we're thinking about expanding. I want to thank my contributors as well as my co-collaborators. I think I saw Jose Ruiz here on the call. It was a really amazing effort, and I think it's something that can be replicated. So if you're interested in knowing kind of what course materials we used, please check out the website. And we would love to see this repeated in other places for developing AI talent. The students were really amazing, and it was really a huge success. And I think with that, I was supposed to do 15 minutes, and I did 16 minutes. So despite me talking incredibly fast, I still was over. Thanks, Ray.
Thank you so much. Feel like you, according to my clock, you do have 1 minute until we're at the
What can you
hour.
do? That's okay. I'll take a. Anybody got a question for a minute? There you go.
I have a question, but I want to give other people the opportunity to ask a question because I fear that mine might be not the main takeaway of your talk. So I'll give everyone a moment to think, and if not, I'll jump on it. All right, I'll go. This, and forgive me if you mentioned this or if this is a stupid question. What are people using the livestock model for?
You know, we've just put it out. It happened as a Google Summer of Code student contribution. So we had a GSOC student develop this, and then we kind of contributed it. And so there's this idea of counting cattle as a way of understanding agroforestry practices as well as deforestation drivers. And so I'm mostly focused right now on drone and manned aircraft because I think that's where the high resolution data is. I am not at all convinced about satellite data. It's strange. I think everyone assumes that I'm working in satellites, and frankly, we're just not there yet with resolution and data processing. And so I'm really understanding that there's a desire to do, cattle detection. How many cattle are there in in Manaus, right? There's like there's a desire to want that question. And we're not there yet from drones and manned aircraft. And so ready to do satellites, not quite there. But there's this huge desire, as you can imagine, for deforestation drivers for livestock detection. I've also been told that, frankly, that there's just there's a undercounting and lack of understanding by major agencies about how many livestock are on their lands. I spoke to someone from the Department of Interior in the United States and the Bureau of Land Management, and both of them expressed the same kind of idea that they're not totally clear about the number of livestock which are foraging on any given time in any given place. And so flying drones over those areas may be interesting. But given the vastness of those areas, we're still thinking about data collection and how that was actually possible. But there is this, I think, mismatch between monitoring agencies and then individual livestock movements that we still don't have a good grasp of, in what season and what phenology and where are they moving. And so that was part of our idea of supporting those efforts. But data acquisition still remains a very interesting question, especially given that satellite's not quite there yet.
Yeah, very interesting. I feel like I've been learning a lot more about about the needs of integrating tech with livestock and especially specifically cattle, like management in North America specifically over the last few months. And it's very interesting. And I think there's a lot of opportunities for implementing useful tech.
Yeah, it's
And
interesting
it,
because
go
it's
ahead.
two ways, and I'd love if anyone else has any feedback here because the ranching community is actually getting quite technical. You wouldn't necessarily have anticipated that that community would be highly technical, but the like large ranching community is getting much more technical. And so we actually, from the commercial side, get people interested in these kind of tools. And then the management side is actually not quite as technical and is still using more traditional methods, as well as like you can imagine that if you're a rancher, you don't love drones flying over your cattle herds. It's not the right ethos. And so it's funny, there's a little bit of mismatch between the economic incentives of large sort of business as well as the management side of it. And actually, I feel like they're going in slightly different directions. We hear a lot more inquiries, frankly, from the like commercial space than we do from the Bureau of Land Management.
Feels like government's always a few steps behind. So that tracks. I know we're over time and I would love to continue this conversation. But really quickly, just before anybody has to jump off, thank you to everyone for joining and for our speakers and their awesome, amazing, engaging, informative presentations. I'm going to end the recording now, but everybody is invited, if you're available, to stick around for our after hours where we have a more sort of casual conversation about, sometimes it's about the topics of today's talks, sometimes it's about other stuff, oftentimes it is about other stuff. So thank you again, everyone, for coming, and we will see you next month on June 25th.